David Spieth here with one more flipped classroom math video lesson. 3 tips before we start. First, you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to catch up with notes or write down some questions. Third, you can turn on the captions and read my words on the screen. So guess what? My school is still in Spirit Week, and today the faculty dressed up as characters from Grease, the movie. So I'm a greaser, and I know you're going to ask, are these real? They are real. They are real tattoos. Never knew that, did you? Okay, so we're going to talk about gradients. That's our second lesson on gradients, part 2. And this one deals with the idea of gradients as rates. And this kind of makes sense when you think about it in terms of just x and y on a graph. The slope, the gradient, is just the rate of change in y based on a change in x. So it's a rate. It tells you how much y changes when x changes. That's a rate of change. Okay? So we're going to tease that out with just this one introductory little problem here. What I've done is I've made a graph of euros versus US dollars. And this is just for like one day, because the rates change a lot. But on this particular day, if you went to a bank with 37 euros, they'd give you 45 US dollars. That's kind of how exchange works. Maybe you're flying to the US and you want to change your euros into dollars. So it's 37 euros gives you 45 bucks. So here's a question for you. What is the exchange rate? If they publish an exchange rate in advance, they're not going to say today's exchange rate is 37 to 45. That doesn't really make a lot of sense. So let's go ahead and do this calculation. I want you to pause for a second and think about how you would calculate this rate. Okay, if you said calculate the slope, you were right. So we have 2 points we can use. That one is 0, 0, and that kind of makes sense. If I give you 0 euros, you're going to give me $0. So I have 2 points. I have this one, and then I have the point 0, 0. And I'm going to call this x1, y1, and this x2, y2. And you'll see why in a second. It makes my calc a little bit easier. So my slope is going to be m equals, pause the video, make that calc, tell me what you get. Let's see how you did. I did my calc. I plugged my 2 points into my slope formula. I calculated it out. I just pulled out my calculator. I got 1.22. So make sure you can get that. Now my next question is, what's missing and what should it be? Okay, what's missing is units. This is not an x and y plot. This is a plot of euros versus dollars. So we have some units in there. So if you didn't think of that at first, now you know that it's units. What are the units? What would you put there? Okay, what it is it's dollars per euro. You get $1.22 for every euro that you give the bank. Okay, let's do a couple of rate problems that will get us to equations and some graphs. So here's our situation. We've got 2 people, and they walk at different speeds. Sean walks at 4 miles an hour, and Nicole walks 9 miles in 2 hours. Okay? So those are both rates. They're expressed a little differently, but they are both rates. So fill in this table. Here's time, 1 hour, 2 hours, 6 hours. And this would be the distance that Sean walks and the distance that Nicole walks. So pause the video and put your head to this and figure out what goes in the table. There's 6 values there. Okay, let's see how you did. Sean walks 4 miles an hour. So in 1 hour, he's going to go 4 miles. In 2 hours, he's going to go 8 miles. And in 6 hours, he's going to go 24 miles. Okay, it's just 4 miles an hour times however many hours he goes. Now, with Nicole, I'm going to start with the 2 hours because we know how far she goes. It's 9 miles. Now I can backwards engineer how far she goes in 1 hour. If she goes 9 in 2 hours, she's going to go 4.5 in 1 hour. And that's going to be the key for me figuring out how far she goes in 6 hours. It's going to be 4.5 times 6, which is 27. So that's the table. Okay, express Sean's rate and Nicole's rate with units and everything. This should be quick. Okay, Sean is 4 miles per hour. And remember, IB also does this weird notation, which is 4 miles times hour to the -1. And so for some reason they must not like using the slash for division, so they bring that up from the bottom of the fraction by making it a -1 exponent. So you should understand that. You might see questions from time to time that rely on you understanding what the -1 power means in terms of units. Okay, and then Nicole's is just 4.5 miles per hour. Now, in the United States, we use this abbreviation for speed, miles per hour. That is miles per hour, like that. Okay, let's make this a little bit more complicated. Let's say Sean and Nicole are a little bit competitive, and so Nicole knows she walks faster, so she gives Sean a head start. So here's the data, the rates. One day Sean has a 1.5 mile head start, after which Nicole starts walking. We're going to assume that they walk at their current rates. The first thing you're going to do is fill in the table. But before we do that, I want you to think about something. Nicole walks faster, so she's going to catch up to him. How might you find out when that's going to happen? I don't need you to pause the video and do a bunch of number crunching unless you want to. Go for it, because I'm going to lead you to that point. But that's where we're going with this one. Okay, so here's the table to fill in. How far have they gone at 0, 1, and 2 hours? Okay? So at 0 hours, Sean already has a head start. At 0 hours, he's gone 1.5 miles. At 0 hours, Nicole has gone exactly 0 miles. Now at 1 hour, Sean's going to go 4 miles more plus what he had. So Sean is at 5.5 and Nicole is at 4.5 because that's how fast she walks. At the second hour, Sean is going to get another 4 miles, so he'll be at 9.5 miles. And Nicole will get another 4.5, so she'll be at 9 miles. So I think you might be able to see where they're going to catch up. But before we answer that question, I'm going to ask a question for you to think about. What's the equation for Sean, and what's the equation for Nicole? So pause the video and see if you can come up with those two equations. Okay, I'm going to do Nicole's first because it's a little bit more simple. She walks at 4.5 miles per hour. So I'm going to write this in function notation. Miles as a function of hours is going to equal 4.5 hours times hours. And that's it. That's what she does. Miles is a function of time, which is hours. It's just 4.5 times the number of hours she walks. Now in this case, for Sean, it's going to be a little bit more complicated. M of hours equals, now we know the rate. He walks 4 miles per hour, so it's going to be 4 times the hours. But he had a head start of 1.5 miles, so we're just going to add the 1.5 right there. Okay? So she walks a little faster, but no head start. He walks a little slower, but he's got a 1.5 mile head start. So these are the two equations that we have for this scenario. But let's do this algebraically, because you might have a situation where it's not as clear as this one. So there's a critical thinking step, after which the algebra is pretty straightforward. Pause the video and see if you can think about what you would use from here to solve for that time algebraically. Okay, if you remembered that their mileage has to be the same when she catches up, that's the critical thinking step. And then what that means is that this equation, because see, that's the mileage as a function of time, has to equal this equation. Okay, let's see how you did. So I just set my two equations equal to each other, and I solved for hours. So I subtracted 4 hours from each side. I got 1.5 equals 0.5 hours. Then I divided by 0.05 to get hours to just be 1. I divide that, and I end up with hours equals 3, which is what we thought based on our table. Okay, another way you could solve this would be to use your graphing display calculator. You could enter the two equations, get their graphs, and then figure out what the intersection is. Remember that when you have two functions, where they intersect is at a point that solves both functions. So in this case, these two lines intersect where time and mileage are the same. And indeed, that's what's going to happen at hour 3. They'll have each gone 3 hours. and they'll go, what is it? It's going to be 13.5 miles, something like that. But let's do the graph. Okay, so my hours on here, I just go up to 3. So hours, time is almost always the independent variable, the x-axis. So let's go 1, 2, 3, 4, 5, and that's hours. And then our mileage, it looks like they're going to cross, say, around 13 or something, so let's go to 15. So 5, 10, 15. So let's find out the y-coordinate of that point of intersection. Hour 3, let's plug that into the Sean equation. Hour 3 is going to be 3 for there, so 4 times 3 is 12, plus 1.5 is 13.5. So it is 13.5 miles where they meet, and it's at 3 hours. So I'm going to go up 3 hours and 13.5. So that's the point, 313.5. And that's where these two lines cross. So let's get Sean's line in there, because that's pretty easy. We know that he's got an intercept at 1.5. When the clock starts ticking, he's already gone 1.5 hours. So that's probably right about there. So here's Sean's line. And then let's get Nicole's line. Now what's the other point for her? Think about that for a minute. Well, at 0 hours, she's gone 0 distance. So the point for Nicole is just the origin, 0, 0. Let's see if I can draw this, because it's pretty close. Not so good, but you get the idea. I gotta make that a little better. That's a little better. So that's how it looks on a graph. And then, of course, after 3 hours, Nicole is going to be getting further and further away from Sean. Now that you've watched the video, take a minute to jot down some notes, some questions, or a quick summary of the lesson. You can also re-watch portions of the video that were a little bit challenging the first time. If you enjoyed the video, please click like. And if you'd like to help me grow my YouTube channel, please click subscribe.